Today we'll talk about session authentication versus GVT authentication. Those are two main methods of how we can authenticate our user, so how we can log in our user, how we can help our user to say that he really is who he claims to be. And let's just start. So we have two diagrams here. The first one is session authentication and the second one is GVT. So let's start with sessions. What happens there? Our user registers or logs in to his account on our application. Then we return session ID in a cookie. And session ID can be a piece of data that links to a session storage. And that session storage contains our session ID and the user. So that's the general explanation. But once again, our user registers and we return a session ID to him in cookies. So cookies, which are sent to our server every request, contain session ID. And then once the session ID is on our application, what we're doing is basically we ask our session storage if we have a user that corresponds to that session ID. For example, you have a user admin. So user with a username admin. And that admin has ID, so session ID 1, and our actor claims to be that admin. If our actor has a cookie with session ID 1, then our application will basically say, all right, what is the user that has session ID as 1 in our session storage? If that user, so with session ID 1 is our admin, then basically we're saying, all right, so that session ID represents our admin. That means that our actor is our admin. So basically that's it. Once again, session ID does not contain any user data. It's just like a link to our user in our session storage. And session storage can be a simple key value storage. It can be a simple cache storage and can be a list of files. It can be anything. Sometimes even people put that session storage in your main database. So session storage as a table or as a collection in your main database. But I do not advise that because session storage can, if your session storage is in your main database, it can lead to a lot of requests coming to your database because you need to query your session storage. And sometimes it's better to split your main database and your sessions to different applications, to different servers. So that's how it works. Once again, session ID does not contain any data. It's just a link to the user which has that session ID as his record in our sessions table. And there is one important addition is that sessions table session IDs can expire. So for example, you have your session ID which only works for 12 hours. After that, your session in your session storage will expire. And we do that to improve the security, because if we would have a constant session ID for the whole project, so imagine that we have a session ID and it's constant, we cannot change it and it will be valid forever. Then it's going to be a problem, because if that session ID gets stolen, our users can basically claim to be other people. So imagine that session ID got stolen and another person asks our app, all right, what is my user? Because you're using session ID of another actor, what you can do is claim to be that person. And then your application will say, all right, what's the session ID of that person? Let me check in sessions. And sessions will tell us that the user of that session is admin or someone else. So it's very, very important to have an expiration time on your sessions. And since we're talking about sessions, and cookies, because once again, remember that session is sent to our actor in cookies. That's very, very important. Only in cookies. There is no body or session ID in the body. There is no session ID in headers or anywhere else. It's just a cookie. And since we're talking about cookies, we can have an expiration time for it's called session. So basically we have an expiration time for cookies, which will only be valid until you close your browser. And that's what you can do with sessions. So once again, session ID only contains the link to our user inside of our session storage. And it's sent in cookies, we receive it in cookies, we send it in cookies. And basically that's it. Session storage is most of the time another application that allows you to see what user has that session ID as his session ID. Yeah, so basically that's it. That's how sessions work. And now let's go to GVT. So as I said, session ID does not contain any information about the user. GVT does contain that information. Let's go to gvt.io website, and that website has a lot of information about GVT tokens and all that stuff, but what's the most important part for us is those windows. So encoded, that's our GVT. So that is GVT token, JSON web token, so I don't need to append token at the end, but that is the token that you're gonna see whenever you have that GVT, whenever you receive that GVT, whenever you send. So that's GVT. And it's encoded, so of course it's encoded, but here we have decoded GVT. And as I said, sessions do not contain any information, but GVT do. And if you're going to look at the right side of our window, we're going to see header. So that's kind of like just meta information about our token, so we're not really interested in that for now. It's just like how you are going to implement it, what algorithm are you using, and so on. What we're interested in are those two windows. So payload. Payload is the most important part of GVT for our users, because payload contains all the data that identifies what user is working with our application. So what user has that GVT. What we're doing in GVT authentication, we register or log into our application, and then our application sends us a GVT token. It can be sent in cookies, it can be sent in response body, it can be sent anywhere, because GVT token is just a token. It's not like a technology when we're talking about session, because session is kind of like a pattern, but GVT token is just a token. And if we look somewhere here, method for representing claims securely between two parties. So it's not always about authentication. It can be about different claims, like I did that, and you need to, different claims between parties. So the most popular usage of GVTs are authentication, is authentication, but still it can represent different claims. And if it can, we need a method to send it as we wish. And because of that, GVT can be sent in our body, response body. So JSON web token, what do we have here? Payload is the most important part, because payload contains the information about your user. And whenever our GVT is sent back to the server, so imagine that we want to access the resources that access some protected resources, and we have our GVT. So we registered, we received our GVT, and we send it back to the user or to the application to get our user information. What happens next? Our application decodes the GVT token in order to find that payload, because that payload contains all the information that we need in order to identify the user. So imagine that we have not sub, not name, but imagine that we have something like ID here, ID1, and then email test@mail.com, kind of like that. So you can see our GVT changed because we changed the information, that's obvious, and our payload can be an example of that. And by the way, payload data can be anything, so you decide what you want to store. In our case, we're going to store ID and email. And what's going to happen? App will receive our GVT, will decode the GVT, and then our application will make a request to the database saying, all right, select all from our database where ID equals 1 or email equals test@mail.com. So basically, application decodes GVTs and then makes requests depending on the payload that we have in our JSON web token. That's how it works. So all the information is here, and we don't need to store sessions, because with sessions, when we have our session ID, we have, all right, so that session ID corresponds to that user. And after that, when our application receives that, all right, that user corresponds to that session ID. Our application makes a request to the database saying, all right, what is the information of that user that we need to return to our actor? However, in GVT, we don't need that session, and all of the information is inside of GVT, and we can basically just decode our GVT and make a request to the database. After that. So we decode our GVT, we look at our payload, we identify the user using our queries, so any queries that somehow find your user in your data storage, and that's basically it. That's how it works. So what is the third part of GVT? Because we have that verify signature, so why do we need that? Imagine that I know the email and ID of our admin. So, by the way, anybody can go to that website, anybody can paste your GVT token here and can see the payload data. That's very important because payload data is the information that is accessible to the whole world. You don't need any additional stuff aside from your GVT token in order to access it. And that's really important because what if I know that my application has an admin account of 10, so ID 10, and email of admin@mail.com. As you can see, so yeah, when I change it here, my GVT changes. And if I put the information of another user, so imagine I put the information of my admin, can I just replace my GVT token with that GVT token and act as an admin? Because once again, how does it work? Our actor sends the GVT to the application decodes it, and uses that data in order to get the user. And that's really interesting because what if I change the data to another user and we will access the data of the user that's not us, so our admin data or anybody else? That can happen. However, you have a verify signature, and verify signature is the only thing that protects you from those types of attacks. So anybody can change your payload, anybody can read your payload, and yeah, because of that, I'm gonna say it right now. Because of that, you don't need to put any unsecure information to your payload. So only put something that anybody in the world can see and cannot use against you. So don't put passwords there. Don't put some fields that you don't want other people to see. So anybody can see your payload. So be sure that to put only the fields that can be seen by anyone. All right, so verify signature, what is that? Verify signature is the third part of our GVT. So we have metadata, then payload, and then verify signature. And that signature allows you to encode your GVT and protect it from that types of attacks. So if I change my information from my own user to my admin, I need my secret. So secret is the key that you use in order to verify your GVTs. Because whenever our GVT comes to our application, we don't just decode it using our header and payload. We decode it using our header, payload, and verify signature. And only our application and our developers should not know that, but only our application knows our secret, that secret. And that secret that only our application knows should not be seen by anyone else, because that secret basically says that if you have that secret, what you can do is decode GVTs and create your own GVTs. And that's very, very bad, because if you know the secret, what you can do is have that attack. You have a possibility of that attack. So if you know the secret, what I can do is basically paste your secret here. So imagine that's a secret. Then I can change the information here, and I have a perfectly valid GVT for your application. So the secret is the only part that should not be visible by anyone, and it protects your application from having your GVT created in some other places, like in gvt.io, on hacker's computer, anywhere else. So signature, once again, is a really, really important part because it basically protects your GVT. If you have your own signature, your server, your application will not be able to decode your GVT. And because of that, you can't really put your information here and think that, yeah, if I put some other people's information here, it will work, because you need a signature and your secret. So yeah, that's kind of it. So you need the secret in order to encode and decode GVTs. All right, so let's go to drawbacks and classes of GVT and session authentication systems. So what's the biggest drawback with sessions? What do you think? That's sessions. Session storage is the biggest drawback with sessions, because we need to store our session ID somewhere. And if we store it on the database, so on our main database, we're going to have a lot of requests coming each second. We're going to have a lot of things to consider because, as I said, we typically have expiration time for our sessions ID. And we are going to delete how we're going to delete our records from our database manually. So how How are we going to do that if we set up our session storage in our database, so in our main database? It's going to be really problematic because additional load, additional things to consider, additional queries, all of that may mess up our system. If we decide to have a separate storage, it's not going to be better. Well, it's going to be better in terms of architecture and in terms of load, all of that stuff, but it's not going to be better in terms of the ease of use of our system. Because if we have a separate storage for sessions in our application, then what happens is that we need to monitor that storage, we need to set up that storage, we need to protect that storage, and we need to pay for that storage, which is also really important. And session storage is the biggest problem with session IDs, kind of like that. And also, there is one big problem in distributed computing. I don't really see it as a problem because whenever I create my own microservices or I create some applications when I have different apps working together using some kind of service bus or just HTTP calls or anything else, I don't really see that problem, but a lot of people mention it, so I'm gonna mention it as well. If you have different services in your distributed application, you can share your session storage between different services. So you're going to have a service there and it's going to have access to your sessions. But I don't really see it happening because typically you're going to have one service for users and that service is going to work with your sessions. And like your users will work with your sessions. And if you need to do something with the users, then you can just request or send an event to that user's service. So I don't really see that happening when you have different services that share the same session storage. Maybe if we have different types of sessions in our session storage, like sessions for sessions for users, sessions for companies or something like that. I don't know, but I don't really see it happening. But a lot of people mention it, and the biggest problem with sessions, once again, is that we need to monitor, set up, protect, and work with another session storage. That's the first problem. Second problem is not as vital as the first one because it's called CSRF. And I'm sure a lot of you know about CSRF, how does it work, but basically I'm going to give you an example because it's really hard to explain CSRF in terms of, in plain English. So an example, imagine that you registered or logged in to your bank account and then someone sends you a link. You click on that link and you send all of your money to another account without even confirming anything, without even doing anything, because you have that session ID and you can automatically request or you can automatically command your servers to do anything because you don't have any protection from CSRF. If you're interested in that type of attack, I can create a separate video for that, but yeah, that's basically it. You have commands that run without your permission, kind of like that. And CSRF, it's not like a very vital problem in 2022 because now we have all of the new web frameworks and all the web frameworks that have protection with CSRF tokens. So it was a problem in the past, but now I don't see it as a big problem if you do everything correctly. Yeah, so kind of like that. Sessions have two biggest problems. The first one is that, and the second one is CSRF. What about GVTs? With GVT, we have a very, very big problem, is that GVT contains information. So yeah, let's talk about the most common problems, or they're not that common, but let's talk about stupid problems, as I call them. If you do anything and share your data, your private data in payload, that's a problem because anyone can decode that payload. And by the way, to decode your payload, you don't need your secret. You only need your secret in order to create your GVT and decode your GVT. Decode like completely, but you don't need anything in order. Well, a secret is kind of like you don't need it to decode your GVT because we can see our payload here, but you need your secret in order to verify that that GVT is legit because you have your secret and you created that that last part of your GVT. All right, but the first problem that may arise if you're using GVTs is that you share some secure information in your payload. That's not what should happen. So if you share your passwords, if you share your keys, is admin fields, is verified fields, something like that in your payload, no, that's not the way to go. And be sure not to share a lot of information because it can have an overhead in terms of the speed of your GVT encode and decode functions. So yeah, share only the information that you really need. Then the next problem is secret that is either weak or can be seen by anyone, so secret in a public space or somewhere else. So you need a really good secret in order to work with GVTs. But those problems are really, really stupid, because if you think about that, well, not a lot of programmers will, and not a lot of people will have a very weak secret, and not a lot of people will have a really strange payload with lots of information. What are the real problems of GVT technology? So as a technology, because with sessions we can have our session storage open to the broad internet, and that's not the way to go. We're not talking about those problems. What are the issues with the technology itself? The first issue, and the biggest issue, that if we steal our GVT, we can claim to be our actor. So imagine that we have a hacker. I'm gonna copy it. We have a hacker, and that hacker steals your GVT. Then he can say that, oh, I have the GVT, so everything is legit, I'm that person, I'm that actor. And if you have your GVT, then basically what you can do is claim to be someone else. Yeah, because GVTs once again represent claims between parties. And yeah, kind of like that, you can claim to be someone else, and that's not what we want. There are tons of things on how to protect from that. The most popular one is that so you don't need to share your GVT with anybody, but that's on our users, and we are not responsible for that. The thing that we can do as programmers and as people inside of the company is that we can create two tokens. We are going to have Auth token and GVT token. So instead of just GVT, we're going to have Auth and update token. Both of those are GVT tokens, but the difference is that Auth token is only valid for 1 minute. So Auth token only works for 1 minute. Update token works for let's say 2 hours or 10 days. And Auth token is gonna help us to request the resources that are binded to our account. So Auth token helps you request protected resources and work with them. And because it has an expiration time of 1 minute, if some actor has your Auth token, so if, for example, you steal, so that actor, that hacker, has your Auth token and he's gonna steal it, then nothing very bad is gonna happen, because he only has 1 minute to do any harm to your account. But update token, yeah, and there is a problem with that, because if we have 1 minute to do anything on our account, our users will have to re-log in constantly. And because of that, we have update token. And update token basically requests new Auth tokens from our application. So we have update token that requests and gets new Auth tokens, and Auth tokens help us to request our resources. That's it. If your hacker gets your Auth token, then it's not that bad, because he only has 1 minute, 2 minutes, 5 minutes, not that much time. But if he gets your update token, then he can. But if he gets your update token, then he has 2 hours, 10 days to do some harm to your account. So it's not really a solution, but a lot of people use it. All right, and what is the next thing that we can do is, basically we can, I forgot to tell you about that, but we can also have an expiration time on GVTs. So we don't need to have it, but we must do it, because GVTs, if you don't have expiration, you can use your GVT forever, and that's not what we want, because if that token is stolen, if your computer is stolen, if your data is stolen, then anyone can access your account with GVT, kind of like that. So yeah, the biggest problem with GVT is that if it's getting stolen. The next problem is not related to the authentication, but it's related to the method of handling our GVT, because as I said, sessions use cookies. So we just sent a cookie, HTTP only cookie that cannot be changed from JavaScript. So cookies have a field called HTTP only, and it basically says that your cookie cannot be accessed from your JavaScript. And it helps us to prevent one simple attack. But with GVTs, it's just a token. It's a claim between two parties. And GVTs, as I said, can be received in any way. It can be just in our response body. It can be received in cookies. And if you have your GVT in your response body, then probably you're going to store it yourself. So when you receive a GVT, you need to store it to handle it as a front-end developer. And what's the problem with that? In web browsers, we have two most common ways to store our GVT. The first one is local storage, and the second one is cookie. Always store your GVTs in cookies. Why is that? Let's talk about that. So I'm gonna press F12 on my keyboard and I'm gonna open up my development tools. Here I can write any JavaScript code. If you don't know JavaScript, it's fine, but what we can do is access local storage. So local storage, as you can see, there are tons of things in here, but local storage is the storage for your browser. So it's a storage inside of your browser, and websites can access it to store information between sessions. So imagine you need to store something between sessions, between your browser close and browser open. You can use your local storage. And some people store their GVT tokens inside of their local storage. What's the problem with that? The biggest problem with storing your GVT inside of your local storage is that I can access your GVT from that local storage. So imagine that you have local storage token here, and then some hacker executes XSS attack. Maybe you heard about that. I have a video on XSS attacks, but some hacker executes XSS attack and he can access our token. He can delete it, but that's not going to be a problem because we're just going to be logged out of our site. The biggest problem is that he can send it, that token, because it's in local storage. We can access it to his own website using Ajax request, and he can basically send the GVT to his own website and use it as he wishes. So that's the problem with storing your GVT in the local storage. And always store your GVT inside of your cookies. So in application cookies, GVT.io, we have different cookies, and that's how you need to store it. Not all of those are GVT, but what you need to do is always store your GVT in HTTP only cookie with secure, forgot the name of that, with secure fields turned on, kind of like that, because HTTP only cookie allows you not to access your token, your cookie, from your JavaScript. That's really, really important because XSS attacks are the CSRF attacks of GVT. So with sessions we have CSRF, with GVT we have XSS. And yeah, that's kind of what it is. The next problem with GVT, and the last problem is not that important, but sometimes it is that we can't invalidate GVT automatically. So we can't invalidate GVT ourselves. What do I mean by that? Imagine that all of our users get hacked, or all of the sessions get stolen, like all of the sessions. What we can do in session example, we can just either flush our session storage, we can delete all of the things in session storage, or even if one user's account gets stolen, we can just delete that record from our session storage. With GVT, there is a problem because with GVT, we only have, what do we have? We have nothing. We don't have our own storage. All the information that we need to get is inside of GVT. And if all of the GVT tokens get stolen, well, we can change our secret and it's gonna help. But it's not gonna help all the time, because if some GVTs, so imagine you have 10 GVTs and 3 out of 10 got stolen or got misused by someone else. You can't really invalidate those 3 GVTs, like exactly those 3 GVTs. If you can, you're gonna set up a different storage. You can set up different storage like that. You have like GVT blacklist, and then query that blacklist for GVTs that are not valid anymore. But it's not gonna be very, very good because you can just use sessions in that case, because you have the same thing, but GVT is less secure than sessions because GVT contains your information, and you can't invalidate GVTs automatically, precisely. So automatically and precisely, because it's going to be a really, really hard thing to do in terms of the tools that you have, because GVT is only a token, and if your application just gets the token and queries the database as it should do in GVT schemas, then it's going to be really hard for you to invalidate it. It's going to be literally impossible. But with sessions, we can just flush the session storage. And those are the two ways of authenticating our user. So either use sessions or GVT. Of course, authenticating our user in normal web applications. What's the way that we're going to use in our Exchange? Because that video, I don't know if I said it before or not, but that video was only created in order for you to understand the difference between sessions and GVT. But the main idea is that we need to pick a method of authentication in our exchange, in our FinDev exchange. And I'm gonna go with sessions because those are much more secure. So we're gonna set up our Redis as our session storage, probably Redis, I don't know for sure, but probably Redis. And yeah, maybe we'll use GVT, but not for authentication, maybe for some other claims. But that's kind of it. So leave your comments. What's your favorite way of doing your authentication? What are other problems with GVT? What are other problems with sessions? And yeah, whatever you think about the video. So thank you for watching. Leave a like, leave a comment. My name is Andrew. Subscribe to my channel, and bye bye.